Okay, looking here, guys, solving simultaneous linear equations graphically. Okay, three previous videos to this looked at solving a pair of equations by inspection and substituting in to check that. Next one looked at coincident lines, okay, which is where the equations are essentially identical and those two lines lie on top of each other. And the third one was about equations with no solution. So we're going to go through the three pairs of equations here, okay, and we're going to see whether there is a solution, okay, whether they are coincident lines, or whether there is actually no solutions whatsoever. Starting with the first one over here, to enable to work with these equations, we need to make sure they're in the form of that y equals mx plus c. Some of them already are, some of them aren't, so we're going to go through and rearrange them, okay, and get them in that form. Now, first one here, y plus x equals 2. We are going to rearrange that to make y equals negative x plus 2. From here, we can identify our gradient is negative 1, and our y-intercept equals 2. All right. This will all make sense in a second. Let's jump down to the second one. We can see that we've not quite in that y equals mx plus c format. So I'm going to divide both sides by 2. And we get to this here. We can identify now that our gradient is 3 over 2. And our y-intercept equals negative 5 over 2. All right, now our gradient's not the same. Okay, we can easily see that. So that means that those two lines will cross over at some point. So there is a solution to that pair of simultaneous linear equations. All right, cross to example B now. Again, some of these will have some rearranging to do. The first one here, y equals 2x plus 5, is already in the form of y equals mx plus c. Now our gradient is 2 and our y-intercept is 5. All right. Looking down to question 2 or equation 2, we can see we've got 3y equals 6x plus 15. So that's not ideal. So I'm going to divide both sides by 3 to get y equals 2x plus 5. All right. Now you can probably already see what's happening here. We've got a gradient of 2 and we've got a y-intercept that's also the same at 5. Now because we've got the same gradient, we know that they don't necessarily cross over, but the kicker with this one is that our y-intercept is also the same. So that means that these are a pair of coincident lines. These two lines, and you can see by the equation when we've rearranged it, is that they're exactly the same. So that's that situation where we have coincident lines and they sit exactly on top of each other. Third one over here, again, both of these we've got some rearranging to do. So the first one, we've got 5y equals 4x plus 6. I'm going to go and divide both sides by 5. Okay, and I'm going to do my gradient, which is 4 over 5. And I'll do my y-intercept is 6 over 5. Okay. Down to that second equation here, I'm going to divide both sides by 10 because I've got 10y here. And that's going to get me y equals 8 over 10x plus 15 over 10 here. Okay. Now, what we can identify as my gradient is 8 over 10, which is also equal to 4 over 5. My y-intercept equals 15 over 10, which would be 3 over 2. Now what we've got between the two is we've got this gradient that is actually the same. My y-intercept, they're different, so it can't be coincident lines. It's just the fact that these have the same gradient and there is actually no solution to that pair of equations there.